Hello everyone, I am Professor Vaibhav Shah. Welcome to my channel. In today's lecture, lecture 22, we'll be learning how to draw a hypocycloid. If you like my content and teaching style, then like and subscribe to my channel to show your love and support. Now, let us begin. Problem 1. Draw locus of a point on the periphery of a circle which rolls from the inside of a curved path. Take diameter of rolling circle 50 mm and radius of directing circle or a curved path 75 mm. So here we have to trace point on the periphery of a circle which rolls from inside of a curved path. Now whenever your circle rolls from inside of a curved path or a circular path, the curve generated is known as hypocycloid. Now here diameter of rolling circle is given, which is 50 mm. So always remember, rolling circle is the smallest circle, and to define rolling circle we will be using small d and small r. So here small d is equal to 50 mm and small r would be is equal to 25 mm. Here radius of directing circle is given, which is 75 mm. So always remember, directing circle is the largest circle. So to define the directing circle, we'll be using capital D and capital R. So here the radius of directing circle is given, which is 75 mm. So that means capital R is equal to 75 mm. So here we have total two data. First, radius of rolling circle small r is equal to 25 mm and radius of directing circle which is equal to 75 mm. Capital R is equal to 75 mm. So now we'll be following these steps for generating our hypocycloid. Most of the steps are common to your epicycloid. So if you know how to draw epicycloid, then you can easily draw this hypocycloid. If you have not seen the previous example or lecture based on epicycloid, then I will insist you go and check that lecture first before moving ahead with this hypocycloid. So now let us start with drawing first the directing circle. So now we have the directing circle radius as 75 mm. So let us take out our rounder and adjust 75 mm radius on your rounder. Now plot, identify any point O on your drawing sheet and try to draw this directing circle with 75 mm as a radius. Now the length of this circular arc would be random. Now after drawing this directing circle, we'll be drawing one another circle, rolling circle. Here the diameter of the rolling circle is 50 mm. So draw your rolling circle with a diameter of 50 mm. After drawing this rolling circle, we'll have to define its direction of rotation. So it is obvious that the rolling circle has to travel from this point to this point. So it is compulsory that it has to rotate in anti-clockwise direction only. Now after that, we will define the center of this circle. After defining this center, let us suppose this rolling circle rolls by one revolution. During this one revolution, any point P on this intersection of these both the circle will start its motion like this in anti-clockwise direction and will come back to its initial position once again. Now at the same time, this rolling circle will travel from this initial point to this final end point somewhere here. Now during this its rotation, it will sustain an angle theta at the center point O. So our next task is to define this angle theta. For that, we have to apply some logic. So the logic is same as that of which we have applied in epicycloid. So 2 pi r is equal to r theta. 2 pi r is the distance traveled by point P over this small circle with the radius small r, and which is exactly equal to distance traveled by the rolling circle over this curved path. So if you want to find out the distance travel on this curved path or the length of this curved path, then we know that the length of this curved path is equal to r into theta. So we have put the same equation here, r into theta. So we have final equation 2 pi r is equal to r theta. Now, if we modify the equation in terms of theta, then we can have the equation of theta like this. Theta is equal to small r by capital R, which is multiplied by 360 degree. We have the values of r and capital R. So let us substitute the values of small r, which is 25, and capital R, which is 75. We'll be having certain value of theta. After getting the value of theta, we have to plot this theta against this line like this. So we'll be having this another line which will define the end position of your rolling circle at the end of the rotation. Now, after having this theta, we have to divide this curved path into 8 number of equal parts. You can also divide this curved path into 12 number of equal parts. It is completely your choice. So here in this case, we are dividing this curved path into 8 number of equal parts. So now these 8 parts can be divided by 2 methods. First, you can put this theta into your calculator and you have to divide it by 8. You will be having one single division dimension, and you will be using that dimension by your protractor, and you can divide this curved path into 8 number of equal parts. In second method, you can use angle bisection method to divide this portion into 8 number of equal parts. I will be using first method. I will be putting this theta in my calculator and dividing it by 8. I will be having one value, and I will be taking that value on my protractor, and I will be dividing this portion into 8 parts like this. 1, 2, 3, 4, 5, 6, 7, and 8 part would be this line itself. Now after dividing this portion into 8 parts, we'll be drawing one line, center line from this point C like this. Now to draw this center line, you have to use this O as a center, and you have to take O till C as a radius, and you have to draw this line. This is a circular center line on which we'll be defining the centers. Before that, you have to define the final position of the circle. In examination, it is not compulsory to you to plot this circle as the end position, because it will take your extra time. Now let us define the various position of these centers like this. Now let us give the numbering like this: C1, C2, C3, C4, C5, C6, C7, and C8. After defining the centers, now we'll divide this circle into 8 number of equal parts. So now, if we have divided this circular path into 8 number of equal parts, then it is compulsory to divide this circle into 8 parts. Now, if we have divided this circular path into 12 number of equal parts, then it is compulsory to divide this circle also into 12 number of equal parts. So now, we have divided this circular path into 8 parts. That's why I have divided this circle also into 8 number of equal parts. After dividing this circle, we'll give the numbering. So number will always start from the intersection point as 0 point as initial point 0. Then in anti-clockwise direction 1, 2, 3, 4, 5, 6, 7, and 8. In examination, you have to clearly specify 0 and 8 here. Now, this is also the starting point or initial point P. So we have to also define this point as P. Now, after that, we have to draw one line parallel to this center line from this point 1. So how to draw this line? So for drawing this line, you have to take O as a center, O1 as a radius. You have to draw this line. This line must pass from your 7th point. So this will be your line parallel to your center line from point 1. After that, you have to create one more line from your point 2. So for that, take O as a center, O2 as a radius, draw one line. This line also must pass from your point 6, and which must be parallel to your center line. Now, let us draw one more line from 3 point. For that, let us take once again O as a center, O3 as a radius. We have to draw this circular arc which must pass from your fifth number point, and this must be parallel to this circular central line. After that, we'll be drawing line from point 4. For that, O as a center, O4 as a radius, draw one circular arc. Now, after plotting this circular arcs, we'll be selecting our radius CP, or taking the radius is equal to your rolling circle radius, which is small r is equal to 25 on our rounder. Put your rounder at C1 and try to cut this line of 1 somewhere here to get this point P1. Now put your rounder at C2, try to cut this line of 2 and call this point as P2. Put your rounder at C3, try to cut this line of 3 and write this point as P3. Put your rounder at C4, try to cut this line of 4 and try to write down it as P4. Put your rounder at C5, try to cut the line of 5 and denote this point by P5. Put your rounder at C6, try to cut the line of 6 somewhere here and try to denote this point as P6. Put your rounder at C7, try to cut the line of 7 somewhere here and give the name as P7. And for last point, put the rounder at C8 and try to cut the 8 number circular line and define this point 8. After defining all these points, you have to just simply connect these points by a dark smooth curve, and you will be having this curve, which is nothing but your required hypocycloid. So now let us see one more example based on hypocycloid. Problem 2. Draw locus of a point on the periphery of a circle which rolls from the inside of a curved path. Take diameter of rolling circle 60 mm and radius of directing circle, or you can say curved path, which is also 60 mm. So here once again we have to trace point on a periphery of a circle which rolls from inside of the curved path. So once again, whenever the circle rolls from inside of the curved path or a circular path, the curve generated is known as hypocycloid. Now, rolling circle diameter is given. So rolling circle is the smallest circle. So that's why small d is given, which is 60 mm, and small r would be 30 mm. Radius of directing circle is given, which is 60 mm. So directing circle is the largest circle. So to define directing circle, we'll be using capital D or capital R. So here radius is given. So that's why capital R would be 60 mm. But if you have the condition in which capital R is equal to twice the small r, then it is the special case of the hypocycloid. So this example is nothing but the special case of hypocycloid in which capital R is equal to twice the small r. So let us check. Capital R is 60 mm and which is twice the small r. So small r is equal to 30 mm. So 30 into 2, which is exactly equal to 60, which is exactly equal to capital R. So this is nothing but your special case of hypocycloid. Now whenever you are having a special case of hypocycloid, in the special case, the hypocycloid is as a straight line. So you will be having hypocycloid as a straight line. And your theta would be 180 degree for your special case. Always remember. So now we are having theta already. So let us start the example. So first let us find out one center point and let us draw one straight line. Now after having this straight line, define this straight line dimension as capital R because it will be the radius of your directing circle. So this is nothing but your radius of directing circle, capital R. After having this radius line drawn, you have to simply draw one semicircle and you have to draw another straight line 180 degree apart. So you will be having this semicircle. This is nothing but your directing circle. After drawing your directing circle, you have to draw this another circle which is your generating circle. For defining your generating circle, we must first define the center of this generating circle. So as we know, the radius of this generating circle or rolling circle is 30 mm. So we have to take on our rounder 30 mm the radius dimension of your rolling circle. Now put your rounder here and try to cut this line somewhere here to get the center C0, which is 30 mm away from your center of your directing circle. After getting this C0 center of your generating circle or rolling circle, you have to take this as a center, 30 mm as a radius, draw one circle, which is nothing but your generating circle or rolling circle, and which must pass from this 0 point here and the center point of your directing circle here. So this will be your generating circle. After that, we'll be dividing this generating circle into 12 number of equal parts. So you have to use your 30 degree, 60 degree, and you have to divide this circle into 12 number of equal parts. After dividing this generating circle into 12 number of equal parts, we'll be giving numbering in this fashion: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Now, as we know, this circle has to travel from this point to this point, so it has to travel in anti-clockwise fashion. So if it is traveling in anti-clockwise fashion, then it will start its rotation from this point 0 in this anti-clockwise direction on the directing circle. Now, if we have divided this circle into 12 number of equal parts, then it is compulsory to divide the curved path of this directing circle also into 12 parts. So for that, we know that total degree of this directing circle is 180 degree. So we have to put in our calculator 180 degree divided by 12. We'll be having one single measurement dimension. We have to put that dimension on our protector, and we can define this point 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 on your directing circle. You can also use your angle bisection method to divide this circle into 12 number of equal parts. After dividing this directing circle into 12 number of equal parts, let us draw line joining from the center of your directing circle to this part number 1, part number 2, part number 3, part number 4. Draw a line from center point to part number 5, part number 6, part number 7, line from center point to part number 8, center point to part number 9, center point to part number 10, center point to part number 11. Now next task is to define this circular center line. So how to define this circular center line? So take out your rounder once again, put your rounder at the center of your directing circle and take the radius equal to center till your C0 point and try to draw one circular line. On this circular line, an intersection of this line 1 will be having C1, intersection of line 2 will be having C2, intersection of line 3 will be having C3, intersection of line 4 will be having C4, intersection of this line 5 will be having C5, likewise C6, C7, C8, C9, C10, C11 and C12 can be plotted. After that, let us construct the parallel circles to this center line. So put your rounder at the center point. Now take the radius from your center point till your point number 1 or point number 11. Draw one parallel circle like this. Now put your rounder at center point and take the radius equal to center point D10 and draw this circular arc like this. Put your rounder at center point and take the radius equal to center point till point number 9. Draw your parallel line parallel to your circular center line. Put your rounder at center point, take the radius is equal to center point till 8 and draw one circular line which is also a center line. Put your rounder at center point and take the distance equal to 7, center point till 7 and draw this circular line. So you will be having a parallel circle like this, parallel circles. After getting this parallel circle, in final stage, let us select 30 mm radius on our rounder. After selecting 30 mm radius, put your rounder at C1 point and try to cut the circle of 1 somewhere here to get this point B1. Put your rounder at C2 center, try to cut this line of 2 somewhere here. Put your rounder at C3 point, try to cut this line of 3 somewhere here to get this P3 point. Similarly, put your rounder at C4 point, try to cut the circle of 4 point here to get this P4 point. Put your rounder at C5 center and try to cut this circle of 5 somewhere here P5 point. Put your rounder at C6 center and try to cut this point somewhere here of the 6 point. We'll be having this point as P6. Put your rounder at C7 center and try to cut the circle of 7. So this is the circle of 7. So try to cut this circle at this point P7. Put your rounder at C8 and try to cut the circle of 8, which is this circle of 8. So we will be having this point as P8. Put your rounder at C9 and try to cut this circle of 9 somewhere here. Put your rounder at C10 and try to cut the circle of 10, which is this circle somewhere here. Put your rounder at C11 and try to cut the circle of 11 here. So this is a P11 point. And put your rounder at C12 and try to cut this circle of 12. So this is a 12 point circle, which is the directing circle itself. So you will be having this point as a P12. So all points would lie on the same straight line if your drawing is correct. So find out these points P0, P1, P2, P3, P4, P5, P6, P7, P8, P9, P10, P11 and P12. After getting all these points, join simply these points by a dark straight line, which is nothing but your hypocycloid of the spatial case as a straight line. Now for solving this example, you can also use a shortcut method. Now in shortcut method, you have to just draw this straight line. On this straight line, you will have to just draw the plots. You have to just plot these points by simply drawing these circles from this 1 point, from 2 point, 3 point, 4 point, 5 point, and 6 point, like this. Now, whenever this circle of 1 point intersects somewhere here, you will identify this point as a P1 on the straight line. On the straight line, whenever this point 2 intersects, you will just identify P2 point. You will just identify 3 point line somewhere here at P3 point. You will just identify this circular line intersect this horizontal line somewhere here as P4 point. You will identify this P5 point as intersection of the circle with a straight line. P6 point would itself be the center point of your directing circle. For P7 point, you have to just find out the intersection point of this circle of 7 line and this horizontal line. For P8 point, you have to just find out the intersection point of your 8 point circle and your horizontal line. For defining this P9 point, you have to just identifying the intersection point of your 9 circle and your horizontal line. For 10 point, you have to identify the intersection point of your 10 circle with your horizontal line. For 11 point, you have to just identify the 11 point circle and your horizontal line, and 12 point would be your last point. So this is your shortcut method. So now this was your spatial case of your hypocycloid. Try to apply your logic for the spatial case, which is mostly asked in examination. So try to solve this example by yourself. If you have any difficulties, try to pause this video and try to get the idea. So this is all from my side. If you enjoyed the lecture, then don't forget to like, share, and subscribe to my channel to show your love and support. Keep learning, stay connected. Bye-bye.